Hello, everybody. Let me share my screen. Okay. Hi, everybody. My name is Michael Haberman. I am the co-founder and CTO at Aspecto, and today we're going to talk about microservices and how to manage them, manage a lot of them. Once you have microservices, they need to communicate with one another, whether it's API or some other form of communication. And when they start to communicate with one another, they may break. And in this talk, we are going to focus about how to manage your microservices from API perspective. Um, the way that we are going to do it is going through a journey. We'll start small, like most microservices projects. We'll start having a small amount of microservices and see how they grow. And this is something that I've seen a couple of times, how this transition goes. And we'll look at this transition from the perspective of trying the complexity of microservices and why it almost by definition going to be a complex solution. And once we will understand that and we'll establish why it's complicated, we can then start ask ourselves, okay, what tools do I need in order to overcome this complexity? So we are going to look at tools, and we are going to look at distributed tracing in specific, and this will be the last part of this talk, and I'll deep dive into that with more details. So why am I talking to you about microservices? So basically, I'm talking out of experience. I've been working on microservices for about 4 or 5 years. I started as an independent consultant and did all kind of projects, monolith to breaking the monolith to microservices, or microservices that grew in scale and they had all kind of growth issues. I have that experience, which eventually led me to start my own startup, Aspecto, which I guess you can imagine also involve microservices. So that's about me. So let's get started. So let's take a look at how traditional microservices projects starts in a company. So usually um, one or two main reasons led the organization to start do microservices. Either their deployment cycle is just way too slow and they want to speed things up, and they think, and quite right, that microservices can help with that. That's one main reason. The second main reason, and let's be honest here, we are developers, we like microservices, we like cool new things, so this is also quite an intensive incentive. So when you start your microservices project, it always starts small, right? You would take a small portion of your monolith, break it out to microservices, or you have a new feature that you can just develop outside of the monolith, and then start with a small feature, and everybody's excited to see how this project and you end up having some kind of simple architecture, your first few microservices. So as you can see in the diagram, you have service A, B, and C. Each service has its own database, and they can communicate with one another. So service A will communicate with B, and A will communicate with the database, and B with this database, and then B to C, and A to C, and everybody is communicating with everybody. And it's all done through HTTP. And you have 1, 2, 3 months into your microservices experience, and everybody's happy. The product is happy because everything is possible fast. The business side, everything is releasing fast. The developers, they are stoked because, well, it's really, really cool. And that's great. And few uh, uh, um, points to identify that you're at the beginning of the journey. So the first thing would be, it's very easy for you to run it locally. When I say it, I mean everything. All your microservices, run them locally. If you can do this, it still means that you're in the beginning of the journey. Um, then, if I would ask you to take your architecture, your whole architecture, and draw it on a whiteboard, it's something that you can do out of memory, and it's quite simple. And if you have a new developer that needs to be onboarded to the system, it's also quite simple for them. So those are the three main things I witnessed that signifies that you're at the beginning of your journey. Now, moving a few months ahead, your architecture started to look like that. Now you have more services, you have tool services, you have a bunch of databases, and they all start to communicate with one another. And as you can see, it's starting to be more and more complex as we go. Right now, if I'll ask you the same question, can you run it locally? I'm not sure it's that simple to run 12 services locally and a bunch of databases. If I were to ask you if you can draw a diagram who is communicating with who, I think that would be quite complex as well for you as experienced developer or for the new developer that needs to work with the team. So it's starting to get a bit more complicated. It's starting to get more complex. So it's hard to see the whole picture, right? That's basically the meaning of I'm able to draw a diagram of my architecture. So for me as a developer to create a solution in this space of microservices, I need to imagine, I need to understand the whole picture. And if that's hard for you, may come up with solutions. So if I look at a service, a specific service, and I'll ask the service review, who consumes this service, or what dependencies this service has, it's a tough question. And if I'll also ask you how two services communicate with one another, so you need to know, we know it's difficult to have to use other technologies, but to what route they are communicating with one another, what is the structure of the table that they are sending with one another. So it's starting to get a bit complex, starting to get the thing that is hard for you to operate. And this is something that I think it's very important to understand. As the picture, as the architecture, as the amount of moving parts gets bigger, the risk that you're taking that you have production issues increases. And this is something that you see when companies go with microservices, they start to have more and more issues that they need to fix. And those issues are originate from the fact that it's hard to figure out. So now I'm trying to say that microservices are a hard fight. It's hard to do microservices without having some kind of an outside development. So microservices is a technology that offers most edge services do not remove microservices. So if you are the face of the current asking today to remove the service, and usually it's not a lot. So it's increasing over time, and it's increasing over time to this impact. And this is something that we need to address. Basically, it's core aspects of microservices. We need to think of how we are using the market. Okay, ready or not ready to grab
Michael, there's seems to be an issue with the sound. Maybe people cannot hear you. They're writing in the chat that something is up with the sound.
Okay, 1 second, let me try to move on to headset. Give me 1 second, please. Sorry about that. Can you hear me now? Is it better?
Yeah, I think it's better. Maybe people could say in the chat as if they can hear you better.
Yeah. Okay. So I think I'll continue. Let me know if the issue comes up again. Okay. Cool. So again, sorry about it. I hope now it's better. So again, back to service A and service B. So now they are not communicating directly. They are communicating via Kafka. And that sounds great because we are persisting our data and we want to be exposed to data loss. Cool. So no more data loss. That's good. But we are kind of experienced enough in microservices by this point, and we know that making changes may take their toll. So try to think like, what problems do I introduce by adding async communication such as Kafka? So the first thing, and this is the theme of this talk, we made the picture way more bigger. So if we had just service A and service B communicating directly, now we're talking through a mediator, through Kafka, with that just making more component. And more component means more complexity. More complexity means that the developer's life is just harder. And then we just, the way it is, it's a one-way street. You're sending the message, you're not getting a response, so you don't know what's happened. And local debugging becomes more complicated. Imagine that you are service B, or you're developing service B, and now you need to invoke service B, and service B consumes messages from Kafka. So either you need to spin up Kafka and somehow insert the messages that you want into Kafka, and then service B would pull it from Kafka, or you're having a new entry point to Kafka where you can, I don't know, simulate an API, simulate a Kafka message using an API call, or all kind of those things. But it's starting to get more complicated, and it's not extremely complex, but for new developer, for more complex situation, this is starting to be an issue. Swagger Open API is not relevant anymore because Swagger is an HTTP kind of thing, and now we are not using HTTP. You can still find solution to document async messages. I'm sure about that. But it's not as mature and have a a rich ecosystem such as Swagger. Now, just to give you the feeling of how it would look introducing Kafka. So this was a diagram that I showed you once we were a few months into the project and using HTTP, talking about Kafka. This starts to look really bad even for a presentation. So it gets really crowded, it gets really complex, and this is one of the root issues with distributed application as a whole and microservices in specific. So bottom line, I hope I convinced you that the bigger the picture, the higher the risk. And also, if the picture is simpler to the developer, if we serve it with ease to the developer, this will reduce the risk of having production issues. So trying to like summarize why it's complicated by nature. Microservices, they're small, they have one responsibility. Over time, you're going to have a lot of them. You don't have one tool that you are using. You may have multiple because one service, it makes sense to use Node.js, but another, you need some, I don't know, some data analytics, so you will go with Python. So you're starting to have all kind of services in all kind of languages with all kind of databases, and of course, async makes it more complex. So far I tried to scare you or convince you that microservices are complicated and they're getting more complicated over time, and that's the way it is. And now the question is, what can we do in order to make it work, to make it easier for us? And this is where I would like to introduce you to tracing or distributed tracing. So distributed tracing is a concept where you kind of do logs, but in a bit of a different way. So let's think about logs for a second, just before we're diving how to distributed tracing works and what it is. So if you have logs in your system, basically you are writing lines of code that eventually you want to tell you a story, right? You want the application to output you a story telling you this is what happened. And thinking about monolith application, you have one line of story, one process that is doing all the job, and it creates in your log system and kind of an easy thing to go through and to read and to understand what happened in the system. Now take your monolith and break it into a lot of pieces, and then your logs are starting to be not one big story, but pieces of stories that you're getting from different processes of your application. And going through this kind of log is quite hard. It's hard to understand that this line of code was sent from service A, but this line of code was sent from service B, and it's really hard to go through those logs. So we are trying to take our game up one level and introduce tracing. So what tracing is doing is basically going to show you the different hops that a request or some backend activity is doing in your microservices. And we have three parts for that. We have an SDK implemented within the code. This is an open source code, OpenTelemetry, by CNCF, the same foundation that is responsible in Kubernetes. You have something to collect data from this SDK, and eventually all of this data is going to one central server, very similar to what logs, with logs, you have something that takes the logs and ships them to Logstash, and then Logstash into Elasticsearch, and then you can view it using Kibana. So we're going to see something quite similar right here. So let's look how the thing works. So you have here a microservice A and microservice B. So microservice A is sending an API call to microservice B. That's cool, and you have the application layer code, and you have OpenTelemetry, that's the SDK that I mentioned earlier. And you have your central traces thing that we would discuss with more details. So I want to know that service A called service B, and I want to know all kind of data. I want to know to which route, and I want to know the duration that it took to handle this request. So when service A is getting a request and is going to send a request to service B, is going to add to the headers a unique ID. And this ID is something that tells service B, hey, you have been called by service A with this specific data. And this is something OpenTelemetry can do automatically because it knows how to patch HTTP and inject those headers. So when service A using OpenTelemetry is going to report on this activity that I got an API call and then I called service B, is going to do it with few data points. The first data point is called a span, and this is represent an activity that started particular time, ended at a particular time in your microservice. It could be an API call, it could be some activity with your, I don't know, S3 with your cloud vendor, it could be a database. So I'm reporting that span 1 did the trick. Sent it to central traces, and span 1 is related to trace 1. Service B is sending span 2, but it also correlates to trace number 1. That means that both transactions happen because of the same trace. And this is how we're able to correlate between two operations in two different containers or processes. So service A is saying, I'm span number 1 with trace number 1. I'm sending it to service B. Service B says, okay, I know this is trace number 1, but I am a new span. I am a different activity, so I'm going to do span number 2. And it's all going to be shipped into my central traces. And if I'll look at the central traces, so let me jump into Jaeger, and Jaeger is basically a visualizational tool of traces. So you can see here that I'm viewing a trace that had HTTP/pub, and that happened in a microservice called publisher. Then you can see here that we have publisher. We've published a Redis message from the publisher service, and it was consumed by the consumer service, which consumed the Redis message. And here you can see two services communicating with one another in one view, one integrated view. And this is going to really help the developers understand what's happening and how all of that is operating. You can see it as a graph if you want, and you can see it as a timeline. It's like up to you what you prefer more. So if we're talking about just viewing for a second how the code of something like that would look. So the code here is basically what I showed you in Jaeger, the visualization tool for traces. This is the code that I needed to write in order to make it happen. So starting to work with OpenTelemetry is extremely simple. This is what you need to do. This is specifically Node.js, but of course you have support for almost any language any mature language out there, like I don't know, C#, Python, Go, JVM family. So all of that is available. And you can see here that the definition is quite short, quite simple. So if I am the publisher service, I'm grabbing this file, I'm initializing it with publisher, which translates to the publisher that we see here. That's the name of the service. And you can see here that I needed to report on /pub. This is the API call I'm getting, and then I can do a start span, and I can end it when I'm ending my request. So basically, I'm reporting to Jaeger, hey, I started this activity, I ended this activity, and the same goes here for the Redis pub sub. So I am creating whatever needs to be created, then I'm doing the publish. On the other side, in the subscriber, I am subscribing to the message, so you will have the same thing. You will have a start span, and you will have end span. It is important to say, just for your knowledge, that you have two approaches that you can take. You can take both together, or you can choose one. This approach is called manual instrumentation, because I manually started a span and I manually closed it. But there is another approach that can talk about automatic instrumentation, and this is a mechanism where everything is automatic. So basically, somehow someone would write a code that patches this function, and we would know by patching it when it started and when it ended, and then we can do auto instrumentation That means all you need to do is to initialize some SDK, and that is it. Everything will happen magically behind the scene. So the implementation doesn't have to be a very hard instrumentation when you do go through a lot of files and make a lot of code changes. This is definitely can be something that is done automatically for you. Don't be afraid that you need to make all the changes your own. So how it is helpful to us? It's helpful when you need to debug something, right? If I want to view how a specific use case behaved, I can just go to Jaeger, view which service called to who, what was the data that was passed between them, and then I can debug it. And also it makes things visual, and we want to understand the big picture. And sometimes visualization can really help with the bigger picture. So I want to zoom in about debugging. So one trick which I think is mandatory if you're using distributed tracing. So if you go to Jaeger, Jaeger doesn't allow you a very good search. It works, you can search, but it's not a very good search. The best way to find what you're looking for with Jaeger is to throw your trace ID right here. As you can see, I'm doing in my day-to-day job. So you get the trace ID representing the issue that you are trying to solve, and you just throw it in your trace ID, and then you can visualize the issue that you had. That means that you need to grab this trace ID from somewhere, and this is where logs come into play. So you can do an infrastructure enhancement to your logging, basically saying every time I'm going to ship a log statement or log entry, I'm going to add the current trace ID. Now imagine the process where you're going to your Kibana because you have some high rate of exceptions, and then you are going to find the log line that is doing all the problems. Now you can grab the trace ID, go to Jaeger, throw it there, and then visualize the whole process and understand what went wrong. One important thing is to say, I'm always saying Jaeger because this is what I use in my day-to-day. But there is Zipkin, which is another open source tool, and there are others non-open source like vendors that you can choose if you want to. So yeah, my suggestion, add your trace ID to any log statement. Now let's talk about visualization, because visualizing stuff makes it clearer, make it easier, and it's a good thing to have. The visualization that Jaeger offers is which service is calling to which service. Now, as a developer, I'm not sure I'm interested in which service is calling which service, but maybe more at the endpoint level, right? Because for me, when I'm writing code or whenever I'm debugging something, I'm not calling user service, I'm calling user service /API /v1 /v something. So then I need to know the endpoint, the route, and then I don't have this. So this is why I think that we need a deeper layer of visualization. So if service A is communicating with B and C, and B communicates with C, so that would be the service level understanding. However, talking about endpoint level, you can see that v1 /items doesn't use service B. And talking about testing and talking about dependencies, this is the level of analysis that I need to have as a developer. So those are the tools that you have, distributed tracing mostly, and we mentioned a couple of others like Swagger and those. But now let's try to think, okay, distributed tracing is really, really helpful when I want to debug something. But it won't help me to understand the big picture. It won't help me to understand it. Well, it will help, but not to the extent that you're looking for. So it won't help you enough with big picture. It won't help you enough with understanding the dependencies. And there are a gap between the way that we develop and what's happening in production. Now let me give you an example. So imagine that you have the SDK, OpenTelemetry, and OpenTelemetry is sending data to a collector, which is a component offered by OpenTelemetry that knows how to get data from SDK and then send it to wherever you want. Basically, an ingestion tool by OpenTelemetry to know how to ingest traces. So those traces need to go to some database. And on top of that database, you have Jaeger. This is how the architecture works, right? So when you are working with OpenTelemetry, you go to Jaeger, but behind the scene, you have some database, which could be, I don't know, a few types of databases, which I think the recommended one is Elasticsearch. So you have a database with all the knowledge, all the production knowledge of how things are operating. So you can use this data, you can have access to this data and use it to your own benefit. So let's assume that you need to generate a mock, right? You're doing some kind of a test, like a unit test or integration test, and you want to have a mock. So how do you create this mock, right? Basically, you create it by looking at the code, you see the code, what kind of response I need, then you create this mock. Maybe you even execute the request or whatever you want to mock, and then you just grab the response that you got, and you just take it. Now it's going to run in any test, and you just hope it's match production. But what if we were go to the database and try and to fetch from the DB all the different real responses that you can get, and then you can just run a query, get a list of all the responses that you are going to get, and then you can start doing more complex mocks that not more complex, more accurate mocks that eventually will just improve the quality of your test, because it's now way more accurate than what's really happening in production versus what we just made up to make sure that our test passes. So I think that you can do a lot with distributed tracing, and I think Jaeger and those tools are critical to making sure that it's easy to debug. But I think you can use this data to more stuff, such as mock. Mock is just one example out of quite a lot that there is out there. So we started very, very slow with 3 services. We grew them up. We now have more and more services, and they started to communicate in an async manner. And we introduced traces to see how they can help us. So that was the kind of process we went through. And eventually, if I need to sum up my tips for you, is do traces and make sure that they are accurate, and always send the current trace ID to your logs. That's going to make your debugging life way easier. And use tracing as you develop, because it's going to allow you to be more accurate and get to know production even better. So thank you very much. Feel free to reach out in any of those links, and the code that I presented, even though it was briefly, is available in GitHub, and you have the link below. So feel free to take a look there. Yeah, so I would love to hear any questions that you might have. Yeah. Okay, so if there are no questions, again, you can feel free to reach out. And you have my email, you have my Twitter. So yeah, would love to answer any question you have. Thank you very much for having me, and I hope you enjoyed it. Thank you.